This is CPM Precalculus, Chapter 3, number 64. So we want to find the height of Mount St. Mellon. So here's the height, h, is this distance here, in the Cantaloupe Mountains. Okay, so this is make-believe situation. But anyway, we have two angle measurements were taken 1,200 feet apart. So here is one point and another point 1,200 feet apart, and the angle measures were taken 35 degrees, 42 degrees, along a direct line toward the mountain. Use these measurements to find the height of the mountain. Okay? So this is doing actual real calculations that you can use to find the height of something far away. So we know so much about triangles right now that there are multiple ways to do this problem. So let's go ahead and look here. Here, don't forget this is a right angle, right? Let's label some of these points along triangles. We have a triangle here with vertex A, B, C, right? There's a triangle here. It's an obtuse triangle. We also have D here, so we have ABD triangle. We have triangle ABD. We have triangle ABC. We also have triangle CBD, right? So let's keep that in mind as we do this work. And I'm not going to label the sides right now. We can label the sides as just using two points. So this is like side AB, right? Side AC here, and so forth. Okay? So what I'm interested in doing to find the height here, right? Our goal is to find the height of this mountain, right? Well, I'm given information about this triangle over here, right? If I can find this side length, side CB, I know that using SOHCAHTOA, that if I go ahead and I look at the sine of 42 degrees, because this right here, triangle CBD, is a right triangle, sine of 42 degrees is equal to the opposite side, which is H, divided by the hypotenuse, which is side CB, right? So if I know the length of side CB, I can solve this equation for H, all right? So my goal right now, I'm going to back up and try to find CB using the triangle ABC. I'm trying to find the side CB using triangle ABC, right? And right now, let's go ahead and draw triangle ABC outside of this picture. So this is A, B, C, and this we know is 35 degrees, and this we know is 1,200 feet, right? Well, what else do we know? If you look at this picture, this right here is a straight angle, and we know that means this angle measurement from here to here is 180 degrees. So if we know this part is 42, then we know this part here is 180 minus 42. So let me go ahead and take out my calculator. I'm going to do 180 minus 42, and I get 38 degrees. 138 degrees. So I know this here is 138 degrees. I'm going to write it in my small drawing here as well. I know that's 138 degrees. I also know angle B, because if I add up all three angles, I get 180 degrees. So I could start with 180, subtract 35 from angle A, subtract 138 from angle C, and I get 7 degrees for angle B. Okay? So using the property that all three angles in a triangle add up to 180, I now have all three angles in triangle ABC. 35, 138, and 7. Okay? So how I can find side BC, right? My goal is to find side BC, the length of the side BC. I can go ahead and use the law of sines, right? Because the law of sines allows me to say, well, sine of angle A here divided by the opposite side, right? Sine of A divided by little a, but that's what we're calling BC, is equal to sine of 7 here divided by 7 degrees divided, or let me put B, sine of angle B, sorry, let me undo that line, sine of angle B divided by side AC, right? And I know angle A is 35 degrees, so I can write sine of angle 35 degrees instead, over BC, BC is my unknown, equals sine of angle B, I know 7 degrees, divided by AC, I know is 1200 feet, right? Now my job is just solve for BC. So I have everything else is known. I'm going to solve for side BC by solving this equation, okay? So first I'm going to multiply BC by both sides. Cancels out here. I'm going to multiply, so I have, sorry, let me go ahead and rewrite this. I'm going to multiply both sides by 1200. That's going to cancel it here, right? And I'm going to rewrite this. So I'm going to divide both sides by sine of 7 degrees. Okay, that cancels that. So I'm left with BC, right, is equal to 1200 times sine of 35 degrees divided by sine of 7 degrees. Okay? So let's plug this into our calculator. You want to make sure your mode here is degrees, right, not radians. So ours is degrees, or mine is right now. I'm going to plug in 1200 times sine of 35 degrees divided by sine of 7 degrees. Okay, that gives me BC is 5,647 point. I'm not going to round here because I will save, if I'm going to round at the very end. But this is just the step in between. So it's 5,647.783966. Okay, and we know that's in feet because all the side lengths are in feet, right? We're told this 1,200 feet. So why do we find this in the first place? Well, remember, we only found side BC because we have the equation sine of 42 degrees, right? And this right triangle here, triangle CBD, sine of 42 degrees is equal to H over CB. So let's write that. Sine of 42 degrees is equal to H over CB. And CB we know is the same as, it's just this side. So that's BC. So I can even write that as, instead of CB, I'm going to call it BC. Same thing, right? I'm just writing it that way because that's how we wrote it here. Solving for H, now we're going to multiply BC to both sides. They cancel out here. We're left with H is equal to BC times sine of 42 degrees. We know BC is right here is 5,647.783966 times sine of 42 degrees. Plug that into your calculator. 5,647.78396 times sine of 42 degrees. And we get H then is equal to approximately, right? We're pretty close, but it's approximate because we're rounding over here. 3,779.1. I'm just going to say 0.1 because at 0, let's say 0.105. Okay, I'm going to put a few extra digits. You can even put 0.10511. And remember, the units are feet. Okay, I'm going to box this answer. And we just figured out how tall or how high a mountain is, right? This mountain right here. Based on looking at 2 points, the distance between them, knowing those, and the angles that they create looking at the top of the mountain. Okay, so this is a pretty cool way to do things, and people do estimate heights. Remember, estimates, not exact, but it's pretty close. It's like off by maybe 0.0001 or whatever. Okay? So that's going to end for us CPM Precalculus Chapter 3, number 64.